Okay, good day, everyone. So again, last time we spoke about the OSI model, right? So in this one, as I promised last time, I want to talk about encapsulation that is used by OSI model itself. Now, again, first of all, let's clear up on what exactly is encapsulation. See, again, encapsulation in very simple words is like putting something valuable inside a protective container so that the information stays safe and organized while you move things around, right? And sometimes also it will tell you what's inside that. So for example, if I'm trying to send something which might break, like a piece of glass or some sort of a decorative thing, right? I'm sending across. So what happens in that case is I will put something like a sticker which is fragile, which tells the person who's handling that box for me that it is something that might break. Okay. Now, specifically in OSI layer, encapsulation is like, really preparing a package or data in this case for a long journey. Now, again, I'm saying long journeys because you might be sending a certain email from North America to Asia somewhere. Now, that's a long journey, right? Now, we don't feel it because we have gone to technology where we can send and send these things very fast. And what is exactly each layer doing? So, since we have so many layers, uh, specifically each layer starting from the transport layer onwards starts to add its own little details, which is on protection, again, ensuring that the data reaches its destination. And this added information is actually called header. And I'll talk about what exactly this is. Okay, so first of all, let's try to compare this with something like some sort of analogy that makes sense, right? So let's say I have an application. Now, again, that could be anything here and here. I could be sending out an email. I could be starting a Zoom call or anything else. Or I should be going to maybe a website to, get a page from Google, from Facebook, anything that could be. So that is my data. Now that is similar to, let's say if I am here and I got my first paycheck, now I want to send my parents a little gift. Let's say I want to send them a smartwatch or something like that. So that is my data. Now what I do is, next thing I do is, so this is something that is created by the application itself, the application layer. Now again, in the OSI layer model, we do have application presentation sessions. So let's collapse them for now and just say that all those three layers give me an application. Now the layer 4 here is the transport layer. What does that do? That says it adds a transport header. Now what does that really mean? So in terms of our analogy is I take that gift, I go to the Canada Post people and I say I want to send this. Okay, and they're like, okay, we have few services. What would you like to use? Which means one is like, okay, simple post where we take it and we just drop it, which is something similar to UDP, which is connectionless. Or I could be using something like a TCP, where it's like, okay, once it gets delivered, I want somebody there to sign it so that I know that it was received by somebody, right? So that is more like a connection-oriented way of doing it, right? So, and it also, TCP is also responsible for identifying what kind of application am I using, right? So like each known application uses a certain port number. This is something, because see, you think about this. If you have a laptop that you're working on, you could be working on multiple things. You could be opening up a browser at the same time, doing something. You could be also doing, your banking at the same time. You could be also answering to some emails or watching something on YouTube, all these different sessions. So when the packet is going and coming back from that specific server, how does it know which application is it for? This is where it tells you, right? So TCP or UDP, depending on which, protocol you're using, each one further says, okay, this port number, right? Now, again, for this purpose of this video, we're not going to go into details of a lot of port numbers, but there are some well-known port numbers that you can download a chart from and kind of look at it. So for example, HTTPS, which is 443, and so on, right? Which is the most common one I just picked up. HTTP, just simple, is port 80, TCP, and so on. DNS, UDP, and so on, right? Now the next thing becomes is, okay, once I've done that, I've decided which transport header for which am I going to use, which service am I going to use. Next thing is, where am I sending it? So IP header is where it adds a layer 3, which is more to do with, okay, where is the location? So who's the sender? I'm the sender, so I'm the IP source who's sending it. And there is a destination IP address also to who I am sending, which in this case would be my parents, at who I'm sending the gift to, right? And then this is layer 3. And the next thing becomes is the data link, right? Now, at data link layer, which is the layer 2, is Ethernet in most cases, where you see the MAC address, so source MAC, and destination MAC. Now, this is something also we'll try to cover in one of the videos, is where we're going to say, why do we need two of these? Why do I need a IP source and destination, and why do I need a MAC and source? So I'll give you a very high level here. Is again, this is, think about this now. So let's say you you took that gift, you left it at your local post office. Now the local post office says, okay, uh, the gift is going to say India. Okay, so since it's going to India, what I'm going to do is I'm going to put it in a big box, and all the other parcels that are also going to India will be put into a big box and sent to the Pearson airport, where a plane is waiting, so that we can put that box in there and send it across. Now, once it reaches, depending on where that plane was going, if it was going to India, so could be going to Mumbai, could be going to Bangalore, could be going to Delhi. Okay, reaches there, then the box is opened up again. So that box gets opened up. Next thing's, okay, my letter was supposed, let's say, going to Mumbai. So I'll put it on a car, which is going to, or a truck, which is going to Mumbai in this case, right? So that kind of is at every hop, or every time you can say that the layer 3 hop changes, the Ethernet header changes. That was on a high level, but see, this is why I need all this, and this is what the encapsulation does. So data is inside, and I'm putting into packet, into packet, into packet, and the data stays safe, and then it opens up. Now, this is how I am sending it. This process of packaging it up, as I said, was encapsulation. And then on the other side, it is something as decapsulation, which means, okay, open up the packet, how I packed it, so it reaches on the other side. Now, I have taken the next slide that I'm going to show you is something that I've taken from practicalnetworking.net website. Again, it's an amazing site. Ed is who runs it, and he's put some great videos. So again, if you want to watch them too, more than welcome. I have also put a link which is also a detail of OSI model, so which would kind of cover our last lecture versus, I mean, this video as well. Okay, so what is happening here? You created data. Again, as I showed in the last slide, you added a TCP. It became a segment. Okay, it went to network layer. You added an IP header, went to the data. It added a Ethernet, and then you put it on the wire, which is kind of sending it, and again, changing into zeros and ones. Again, it could be wire, wireless, doesn't matter. Again, Ethernet. So now you're opening one by one. So you have Ethernet here, you remove Ethernet, now you remove. So again, the decapsulation is the process of removing these headers one by one and delivering the data back to the applications. Now think of this as the left end would be the sender, the right end would be the receiver. One more thing I want to point out here in this simulation that he's showing is at the transport layer, the data with the TCP is called a segment. At the network layer, it's called a packet. At data link, it's called a frame. Sometimes these uh, you know, uh, terminologies are used interchangeably, but the right way of using them is, as I said, it's a frame at the, if it's a frame, that means it's Ethernet header. It's a packet when it's at the network, and it's a segment when it's at the transport, right? Because for example, if you look at Varsh, when we're doing a packet captures for Wi-Fi, we say packet capture, but it's not really a packet capture. It's more like a frame capture, right? Because wireless only exists at layer 2. Okay, so just wanted to make sure that you understand that. Now, okay, as some of you have already seen Wireshark, so let me show you Wireshark here and show you the same thing in action, right? So again, the first thing that you see here is your physical. This is all your zeros and ones, the bits. Then you saw the Ethernet, right? Ethernet. And then you saw the IP protocol version 4, IPv4, which is the network, which is the IP for network layer. And then you have the TCP for the layer 4, and then it's saying that, okay, I'm using the hypertext transfer protocol, which is port 80. Okay, so that's my application, right? And I can also open it up a little bit more if I want to. But again, this is just to kind of show you that this is how a frame really looks like. And Wireshark is just able to show you all that, right? If I go to the Ethernet here, it tells me that within my Ethernet, so it's telling me that what is inside this Ethernet frame. Okay, by the way, in this, I have an IP4 address. It's showing me that. And when I open up a IPv4, it's telling me that there is a TCP inside here, right? So it's showing that, okay, inside this, I have a TCP. So it's kind of, showing you that encapsulation in a frame itself, that, okay, this is something you've captured, but inside this, there are multiple things in it. hopefully this was helpful. Again, and thank you for your viewing this one. And hopefully I'll try to continue adding some more concepts. And again, if you have any specific things in mind that is not making sense to you, let me know. There is not going to be like a series here. So I will pick up random stuff and, try to join them together. Uh, the idea is, again, just to make sure that we are able to kind of, continue to build onto our basic concepts that will help us. Okay. Thank you again. Have a wonderful